I'm going to do an example of a problem using square roots, or just the square root of x will appear in the problem. And I want you to see how remarkably similar this is to rational function examples that I did at the video before the last one. So I want you to compute the limit as x goes to 4 of x minus 4 divided by the square root of x plus 2. Now, if you just try to take x equal, remember the first thing that you want to do with these things is to try to plug in the target value, x equal 4. If you try to plug it in, you'll end up with 0 over 0 like before, so you have to do something algebraic if you want to do this by hand. So I'll show you what I'm talking about. I want to factor the numerator. The x minus 4 is actually factorable in some, just saw that mistake. It's radical x minus 2 in the denominator. So anyways, the limit as x goes to 4 of x minus 4 over the square root of x minus 2 equals the limit as x goes to 4. The x minus 4 in the numerator actually factors as the square root of x plus 2 times the square root of x minus 2. This is like a difference of two squares formula. And so the denominator is not changed, although I extended that vinculum a little too far. But anyways, hopefully it doesn't destroy the rest of this. The limit as x goes to 4 of radical x plus 2. So the radical x minus 2's cancel out. Now I have the limit as x goes to 4 of radical x plus 2. I can just plug the 4 in. Oh, I don't want that. I just want to go right into the answer right now. So instead of x, replace x with 4. So I'm going to have the square root of 4 plus 2. And that will equal 4. And of course, since we're just learning these things, I'm assuming you're not an expert at this. So I like to check these as often as I can. And I'll put the function into my y1 as usual. So we'll put x minus 4 in parentheses. Divided by, and in parentheses again, the square root of x minus 2. You got to move the cursor over so that you don't stay under the vinculum. And I'm not going to bother graphing it. I'm just going to go right to the table. That seems to be the quickest way for me to find out an answer. I will set my table start at 4, and I'll set my delta table at 0.0001. And then I'll take a look at the table values. So you can see, of course, there's an error when x equals 4. But look at the numbers around it. I see 4. It's not actually exactly 4, you know that, but the calculator will round to like 5 or 6 decimal places. So let me paste that in as my evidence that supports my answer. So I'll circle the important stuff. When x is very close to 4, y is very close, also close to 4. Oh, that's interesting. So that checks out. Now, this is typically not the way that this type of problem is solved in a calculus book, or most people don't actually do what I did. They don't factor. So let me show you a second method real quick that is, I guess, more standard than what I just showed you before. So let's try the limit as x goes to 4, x minus 4 over the square root of x minus 2. This time I'm going to multiply by something called the conjugate. In the denominator, the conjugate of radical x minus 2 is radical x plus 2. So I'm going to multiply the numerator and denominator by radical x plus 2. then the numerator, I'm not going to multiply it out. I'm going to leave it as x minus 4 times radical x plus 2. However, the denominator, if you use the difference of squares formula, or just the FOIL method, look, radical x times radical x will give me x. Then I get 2 radical x minus 2 radical x. They cancel out, but negative 2 times 2 will be negative 4. So you see x minus 4 cancels now, and I'm left with limit as x goes to 4 of radical x plus 2, which is exactly where I ended up last time. So pick one of these two methods. I don't advocate for one over the other.